Hi everyone, and welcome to day 2 of limits. A lot of what we talk about today is going to be very similar to what you practiced yesterday. We are still looking at graphs, but now you're going to be making your own graph and then finding the value of the limit. So again, I like to always go back to these learning targets. Again, we're still looking at graphical limits, but now we're really focusing here is either finding the value of a limit using a graph that we make, or finding the value of a limit using the graphing calculator. So again, still looking at a graph, but you're either generating the graph yourself or using your calculator to do that. So we're going to start off here, and this will give us a little more practice with those piecewise functions. So the first thing we're going to do is graph the piecewise function, and then we're going to evaluate the limit using the graph. So let's get started here. I'm going to look at the first piece of my graph here, which is x squared plus 4, and that's for x values less than 0. So I know to the left of my x-axis here is where I'm going to be plotting this curve. So because this is less than 0, I know at 0 I'm going to have an open circle, so I'm going to make myself a note there. So if I were to plug in 0, I get 0 squared plus 4, which gives me a value of 4. And again, I'm going to be open at 4. And then I'm going to work my way to the left. So I'm going to have negative 1. Well, negative 1, that quantity squared is just a positive 1, plus 4 gives me 5. So I have negative 1, 5. Negative 2, if I square that, gives me a positive 4, plus 4 is 8. And so there I can kind of see that piece of my parabola. So I'm going to sketch that in. Now remember, if you're still struggling a little with the piecewise, you can always make those tables for each part. All right, let's look at our second piece here. I'm going to do that in green. This says that f of x is equal to x when x equals 0. So that's just at the 1 point. So what that's telling me is when x is equal to 0, my function value is just the same as the x value, so that's 0. So we're going to have a closed circle there. Now my last piece is for x greater than 0, so we're back to another open circle. So if I plug in 0, I get 3 times 0 plus 4, which is going to give me 4. And again, I was already open at 4, so I have another open circle there. And now I'll just continue on. So when x is 1, I have 3 plus 4 is 7. When x is 2, 3 times 2 is 6 plus 4 gives me 10. And I can see I have my linear piece of my graph there. And today I did come prepared with my straight edge. So we have a function that looks like that, and it looks like it's pretty okay on the screen, but I want to emphasize this value here. So that was really the only new piece for this section. Now we have a graph, so we're going to evaluate the limits using that graph just like we did on day 1. So if I look for question 1, as I approach 0 from the left, as I'm approaching from the left-hand side here, I'm approaching the y value of 4. As I approach 0 from the right, I'm also approaching 4. Now, for f of 0, we actually know that that's equal to 0. And we know that's okay. We have a two-sided limit that's equal to 4. The function value itself is 0, but we know the function value does not have to be the same as the value of the limit. Now, as I approach positive infinity, so as my x values get bigger and bigger, I can see that my y values are going to do the same thing. So my limit is going to be positive infinity. As my x values approach negative infinity, so off to the left here, I can see my y values are still going to get infinitely large, so the value of the limit is infinity there as well. Now, for the next piece, we're going to use our graphing calculators to find the value of these limits. For right now, I don't want you to worry about filling in the buttons. We'll kind of talk through this in class tomorrow because this is one of the trickier pieces I find. I just want you to be able to see a couple of examples right now. And probably for our purposes, I'll just show you one where we're finding the limit at a specific value and one where we're looking as x approaches infinity. And like I said, we'll kind of regroup on this in class tomorrow to make sure we've all got it straight. So when I'm using my calculator, the first thing I want is a graph of that actual function. So I'm going to go to my y equals, and I'm going to type this in. So I'm going to use my alpha y equals to get a fraction here. I'm going to type in the sine of x over x. Now, since we're using sine, one thing I want to point out is that in calculus, it's really important that you're in radians mode. So if you go to your mode here, you want to make sure that you have radians selected. That's going to actually make a big difference as we go through the year. So I'm going to go back to my y equals, and here's my graph. Now, sometimes it's going to be really easy to tell just looking at the graph what the value of that limit is. So as I'm looking at my graph, I would say that that limit is equal to 1. But I want a way to double check that to make sure it's actually 1. So what I like to use the table feature in my calculator. So I'm going to go to second window. So I get my table set. And I'm going to tell it, since my limit is approaching 0, for my start value, I'm going to type in 0. And I want it to auto-generate everything else. So let's look at our table. So here's my table. As I scroll up, I can see the values approaching 0 from the left. Those are the smaller than 0. And I can see as I approach 0 from the right. And it looks like, even though I'm not defined at 0, right, because of that denominator, I can see both from the right and left-hand side I'm approaching 1, so I know what I saw in my graph is correct. Now, let's look at number 3. So again, I'm going to go back to my y equals, and I'm going to type in my function, minus 2x, and on the bottom I have 6x squared. And I'm going to go ahead and graph that. Now, I don't see a whole lot happening here, and this one's a little trickier because now it's looking as x goes to infinity. So I could change my range, or my window, and make my x values infinitely large, but again, I find it helpful to use the table. So I'm going to go back to second window, but now I want it to ask me for the x values. So now when I go into table, I'm going to just type in larger and larger values of x. So I might start with 100, and then 1,000, right? And bigger values. And I can see as big as it gets, it's always approaching 1/2. So again, I find that table is a really nice way to find these limits when the graph maybe isn't totally clear. Like I said, we'll go over these 2 examples in class tomorrow, and we'll kind of get more information recorded here about the buttons, and I'll show you another way to do this, but we don't need to worry about that for right now. So the last thing we're going to talk about then is when we're actually given a table of values. So now it says the table of values for the given information has been provided, and we're going to use the table to evaluate the limit. So for my first one here, it says based on our numerical values, we would say that the limit as x approaches 1 of f of x, and we have to find that limit. Now remember, this is asking for a two-sided limit, so I need to consider the values coming from the right and the values coming from the left. So looking at my data, as I approach 1 from the right, it looks like my values are getting closer and closer to 2. Now, as I come from the left, they're getting larger, but it also looks like they're approaching 2. So I would say that that two-sided limit is 2 because both sides agree. Now, it says sketch a possible graph close to x equals 1. Now, the reason we say close to x equals 1 is because we don't know anything about the graph beyond these values in the table. So what we need to show here is just a very small section of the graph. So we're approaching 1, and I know my values are around 2. Now, I don't know what's happening at x equals 1 because they haven't actually told us the function value there. So we may know that value and we may not. So for right now, I'm just going to put an open circle there. What I do know is that from the right, my values were larger than 2, and they're getting closer to 2. So I might show something like this. Right? From the right, they're getting smaller and approaching 2. As I approached from the left, they were getting larger and approaching 2. So I might just show it kind of going uphill like that. That's really all we need you to be able to do there, is just to be able to kind of visualize what would this data look like in a graphic representation. So the same idea then for my second one here. Again, now we're looking at x approaches 0, and we need to consider from the right and the left-hand sides. So as I come from the right, my x values are getting bigger and bigger, and it would look like they're approaching 1. If I consider from the left side, I have the same thing. My values are increasing, and they're also approaching 1, so that I feel comfortable saying that the two-sided limit is 1. And again, we're going to sketch a possible graph. So I've got x is 1, and here's my y value of 1. Again, I don't really know what's happening at 1. It may be that that function value is defined. I just don't know based on the information I'm given. But what I do know is that I was increasing coming from the left, or excuse me, from the right, and I was increasing coming from the left. So I could just draw a small chunk of my graph that shows the behavior from either side. All right, that is it for today. Have a great evening or day, and I will see you tomorrow.